Nuclear fusion occurs within the sun's core, converting hydrogen into helium. This process releases vast amounts of energy in the form of electromagnetic radiation. Extreme pressure and temperatures, around 15 million degrees Celsius, are required to enable nuclear fusion. Energy generated in the sun's core travels outward through the radiative zone. Within the radiative zone, photons randomly bounce around, gradually transferring energy. It can take hundreds of thousands of years for photons to traverse the radiative zone. The convection zone is characterized by the upward movement of hot plasma and the subsequent downward movement of cooled plasma. This convective motion within the sun's convection zone is analogous to the process of boiling water. Convection efficiently transports energy from the sun's interior to its surface. The photosphere is the visible surface of the sun. Granules are small, bright areas on the photosphere's surface. Convection causes the formation of granules on the photosphere. The chromosphere is a layer of the sun's atmosphere located above the photosphere. The chromosphere is typically visible during solar eclipses. The reddish color of the chromosphere is due to the emission of hydrogen alpha radiation. The corona is the outermost layer of the sun's atmosphere. The corona extends millions of kilometers into space. The corona's temperature reaches millions of degrees Celsius, much hotter than the photosphere. Nuclear fusion involves hydrogen nuclei combining to form helium. This fusion process releases energy in the form of photons and other particles. The energy released is governed by Einstein's equation E.m.c. 2, where mass is converted into energy. The sun emits approximately 3.8 x 10, 26 joules of energy per second. This energy output has remained relatively stable over billions of years. Data visualization illustrates the consistent and immense energy production of the sun. Sunspots are temporary regions on the sun's surface characterized by intense magnetic fields. Sunspots appear darker because they are cooler than the surrounding photosphere. The strong magnetic fields within sunspots suppress convection, leading to reduced surface temperature. Solar flares are sudden releases of energy from the sun's surface. Solar flares are often associated with sunspots. Solar flares emit radiation across the electromagnetic spectrum. Coronal mass ejections, CMEs, are significant expulsions of plasma from the sun's corona. CMEs involve the release of substantial magnetic field energy from the sun. These ejections can travel outwards into the solar system, potentially impacting planets. The solar wind is a continuous flow of charged particles emanating from the sun. These charged particles interact with planetary magnetic fields. The solar wind also interacts with planetary atmospheres. Earth's magnetic field deflects most of the solar wind. The magnetic field protects the planet from harmful radiation. The interaction between the solar wind and Earth's magnetic field creates the magnetosphere. The sun's energy is the primary driver of Earth's climate system. Solar energy influences temperature, weather patterns, and ocean currents. Changes in solar activity can affect Earth's climate. Plants utilize sunlight to convert carbon dioxide and water into glucose and oxygen through photosynthesis. Photosynthesis is the fundamental process that forms the base of most food chains. The process of photosynthesis involves the transformation of light energy into chemical energy. Auroras, also known as the northern and southern lights, are created by charged particles from the solar wind. These charged particles interact with Earth's atmosphere near the poles. This interaction results in the beautiful display of light known as the aurora borealis or aurora australis.